Alright, so an angle, it is formed by two rays with a common endpoint. So notice how my two rays are here, it's got a common endpoint. Anybody tell me what this common endpoint is called? The vertex. Thank you. Okay. What do you suppose these rays are called in my angle? The sides. I know. Kind of an obvious one. Some of you are thinking too hard. Okay. We're going to name angles with 3 letters. Okay. The middle letter has to be the vertex. Okay. Now, if there's only one angle, I can go by 1 letter. So like I could call this angle B, but more often than not, you're going to see angles like on page 18, where there's more than 1 angle coming out of a vertex. Okay. So, in this guy, we call it angle 3 letters, A, B, C, or I can call it angle CBA, yep. As long as that B is in the middle, I can call it either one. Okay. Little vocabulary rule, if I classify this guy, what's he called? Acute. Acute angles, how do I know if it's acute? Less than 90 degrees. So what's this guy called? Obtuse. He is greater than 90 degrees. Okay. How about this guy? It's a 90-degree angle, and we call it a right angle. And that's what that little box in there means, is that it's a right angle or that it's 90 degrees. Okay? How about this guy? Anybody know how many degrees he is? He's 180 degrees. Anybody remember what it's called? It's called a straight angle, because it's a straight line. Making things complicated. All right, so what is the vertex in this guy? It's K. What are my sides? Okay, good, but be careful because since it's a ray and it's pointing this way, we have to name it KJ, yeah. Okay, and then my other side is going to be KL. So your first letter has always got to be the vertex. Okay, 3 ways we can name it. Angle K would work because there's just 1 angle there. Angle JKL or angle LKJ. Notice how I have the angle symbol in front of them so that I know you're talking about an angle. Okay, you have to put that angle symbol. Okay. Congruent angles. Okay. If the measure of angle A equals the measure of angle B, okay, then we can write that congruent statement. And we can say angle A is congruent to angle B. Alright, so remember you talked about it Tuesday, you talked about angle bisectors, right? Because we talked about a segment bisector. What's a segment bisector do? Cuts a segment into 2 equal parts, yeah. So what do you suppose an angle bisector is going to do? It's going to cut the angle in exactly half, okay? So it is a ray that divides an angle into 2 congruent angles. Okay, so this guy in the diagram at the right, what is my ray that's bisecting it? BD. So BD is my angle bisector. So therefore, what are my two congruent angles? Angle. Remember how many letters am I going to need? Yep. Well, careful, because ABC is the whole angle. So that's the one that's getting cut in half. So ABD, because this angle right here, ABD is congruent to angle DBC. Yep. Right, because it's cutting those into two. Okay. Perpendicular lines. Can anybody tell me what perpendicular lines are? Ooh, that's close. That's parallel. So that's another special set. They cross, but they cross and they do something special when they intersect. There you go. Okay? It is two lines that intersect at a right angle. So in order for them to be perpendicular, okay, they're going to form right angles. Okay, the symbol looks like that. Looks kind of like you're almost going to play hangman. Okay, so over here I can say that line L is perpendicular to line M. And what that tells me is that they cross and they form a 90-degree angle. Okay. So we know what perpendicular means, right? It means that it forms a right angle. And what's a bisector mean? Does it mean to bisect something? Cuts it in half. So in this case, okay, it's going to be a 90-degree angle, and it's going to cut the line in half. Okay, so it is a line, segment, or ray perpendicular to a segment at its midpoint. Okay, so what is my perpendicular bisector over here? What's the name of that line? How do I name this line? LM is the perpendicular bisector to, how do I name the other line? P2. There you go. Okay, because LM, it intersects this line, it forms a 90-degree angle. And remember that these little dash marks mean that those two lines are congruent. Right? Alright. So, another name for CBF. FBC, good. Angle FBC. Don't forget your little angle symbol. The sides of EBD. Yep, BE, so ray BE and ray BD, yep. Those are my two sides. Okay, it says classify ABC. So ABC is this guy right here. Straight angle, yep. On the straight line. Okay? We need an example of an obtuse angle. There is a plethora of choices up here. There's lots of obtuse angles up here. Who wants to give me one? What? E, V, D. That will work. That is obtuse. Angle E, V, D. All right, how about E? Two congruent angles. All right, so I'm hearing EVA and CVF. Angle EVA, angle CVF. Very correct. How did you know? How did you know that they were congruent? These little arches in them, right? Okay, so these arches right here mean that those two angles are correct, or are congruent. Okay, the two lines mean that lines are congruent. The two little arches in there mean that the angles are congruent. Okay, and then my perpendicular bisector, what line cuts another line to form a 90-degree angle and cuts it in half? Okay, so AC is the line, okay, that we're talking about. It's got a 90-degree angle, it gets cut in half. What line cuts it in half? Line. So how many letters? 2. So what line cuts that guy in half? BD. Yep. BD is who cuts that in half. Somebody said EF, which you are correct in saying that that cuts it in half. The only thing wrong with EF is that it doesn't form that 90-degree angle. Okay? Impressive that you saw that. I didn't even run through my head. All right, flip the page. Angle addition postulate. What did the segment addition postulate tell us? What did we do with the segment addition postulate? That was where if I have small portion of the segment plus another part of the segment equals the entire segment, right? Okay, so this guy, if I have this, it means that small angle, angle A, B, D, plus the other small angle, so the two angles that are hooked together, angle D, B, C, is going to equal the entire big angle. So it equals angle A, B, C. Does that make sense? The two parts added together make the whole. Okay, so in number 1, ABD is 48, DBC is 78. So what's ABC going to be? What do I do with those two? Add them together to get 26. You were right. I just kind of added in my head. Don't mind me, I was your teacher for the year. Alright, so DBC is 74. The whole thing is 119. So now what do I have to do to find ABD? Subtract them, and we get 45 degrees. Okay, so if we're looking at number 3, it tells us our two pieces, tells us that the whole thing is 141. So how can I find x? equals 141, okay? Two parts added together equals the whole thing. So 23x plus 3 equals 141. 23x equals 138. So x is, might have to punch some buttons in. It's okay, you can exercise your finger. I know Fian's trying to poop you guys out today, but 6. Okay, so now if x is 6, what's p, q, s? What do I have to do? Plug it in. 13 times 6 plus 4 gives us 92? 82? Okay, and SQR is the same thing. 10 times 6 minus 1 gives us 59. Okay, it's not so bad, right? Okay, hopefully not. Mostly it's just some new vocab. These are all the same exact thing that we were doing. If it says that it's a straight angle, it means it's how many degrees? 180. If it says that it's a right angle, that means it's how many degrees?